Hello everybody, this is the third video clip for the chapter 2, and we are going to find a derivative of a trigonometric function, especially the sine and the cosine. Okay, so from the definition of a sine and a cosine, which is defined on the unit circle, you remember, so this one, it is what x squared and y squared equals to 1. We are going to let this point P, okay, depends on the angle theta from the positive x-axis, and this point P, the coordinate will be a cosine theta and the sine theta, okay. And then actually, I mean, some of you may not know, but actually if you draw a tangent line, so this one is actually a tangent line to this circle at the point 1 0, okay. And then you just draw a line passing through the origin O and P, and then it will cut that A, okay, the tangent line at Q, okay. So actually this one, okay, the length of this one will be, so let me erase this one first, okay. So here your P, okay, the coordinate of P will be cosine and sine, right? And then actually the length here, okay, is the value of the tangent theta, okay, the value of the tangent theta. So from the picture, you can see roughly that the area of the angle, the triangle AOP, which is this one, this triangle, okay, it is bounded by the area of the sector. So the sector is look like a triangle, but you have this one, okay, a curve of one section of your cycle there, okay, is a sector, okay, and this sector is also bounded by the area of this one, right? A bigger right triangle here, okay. O A Q, okay. Okay, so you have this relation from the picture. So which one that we can find the area? So let's look at this one. This one actually, because your P, the coordinate of y is sine theta, right? So if you just drop this one as the height, okay, for this triangle, so it will be 1/2 the base times the height, is it? Okay, so the base is the radius of this side circle, which is 1, and your edge is the height that you just dropped from that P, which is a sine theta, right? So it means that the area of this triangle is simply 1/2 sine theta, okay. How about the area of this sector? Okay, the area of the sector, okay, if this one is R, if this one is A, then the area will be 1/2 RA, okay, the area of this sector. However, this R is simply 1. How about this theta? Actually, the theta has the relation among the angle and the length of this arc and the radius, right? For example, this one, it means that theta equals to A over R. But this one, your R happen to be 1. So the arc here, okay, and the angle theta here, they have the same real number value, okay. So this one you need to measure it in terms of real number. So this one is also theta. So it means that the area will be 1/2 R A, okay. So it's just 1/2 of that theta. And then how about this one, the area of this one, it is again 1/2 the base, which is B, times the height, which is what, 10 theta. But the base here is a radius, right? And your radius is again 1. So it depends on 1/2 10 theta, okay. And what is the tan theta? It is actually the sine theta over cosine theta, right? So what we are going to do is that we just try to get rid of all the sine, okay, on the left end and the right end, okay. So, and also the 1/2, we can also cancel, all right. So after you cancel the 1/2 and then you divide the whole thing by sine theta, it means that on your left hand side you got 1. On your right hand side, your sine on top is already gone, so you have 1 over cosine. And then at the middle, you have a theta over sine theta. Is that familiar? Okay, you may think that, hey, this was familiar. You can either come from this or you can flip it a little bit, because this is just like something that we are going to familiar with later on. So let us flip it a little bit. By flipping, okay, actually after the flip, then the sign of the inequality will also be flipped, okay. So after you do the flipping like this, you reverse again all the inequality. So now the left end become cosine and the right end become 1. But of course, the middle will not be changed, right? It will be sine theta over theta. Do you familiar with this kind of notation? So this one we can we can use the squeeze theorem, right? We can use a squeeze theorem, and you let your theta goes to 0. Okay, you let your theta goes to 0. So as your theta goes to 0, the cosine theta don't the cosine 0, don't forget it is 1. And this one, of course, the limit of a constant is 1. So if the limit on the left end and the right end are equal as your theta goes to 0, it means that the limit uh, of the sine theta over theta as your theta goes to 0, it will be 1. Okay, so this one is the limit concerning a trigonometric function, and this limit will be helpful when you want to find derivative of a sine and a cosine. Okay, so keep this one in mind first, that the sine theta over theta, as your theta goes to 0, it will go close to 1. Okay, so can we manipulate it a little bit? Okay, so how about this one? Okay, so as you see 1 minus cosine or 1 minus sine, one thing that you may need to think of is that you have a cosine square theta and sine square theta equals to 1. And we also have sine square theta equals to 1 minus cosine square theta, right? And this one actually can be factor into 1 minus theta and 1 minus cosine theta and 1 plus cosine theta, right? And it seems that we already have one here. So why don't we try, because what we have, okay, at the beginning is the sine, right? But this one we have no sine. So how are we going to create the sine out from nothing? Okay, actually it's not out from nothing, but it's from the cosine. So we have this one. So this is the original problem, and then so you just try to multiply it by the conjugate of this one. Okay, so on top it becomes a what? It becomes 1 minus cosine square. Okay, and on the bottom you got this one and then cosine theta. Okay, so on your top right now, it is a limit as your theta goes to 0 of sine square over this one and 1 plus cosine theta. Okay, so can you manipulate it into this one over theta, one of them, and then this is one of them over 1 plus cosine. Okay, so that for this limit, okay, the first one, the limit is already one that you know, and then the limit of this second one multiply, you got what? 0 on top and then 1 plus 1 at the bottom, and it becomes what? 1 multiplied by 0 over 2, which is 1 and 0, so it will be what? 0. So it means that the limit of this function 1 minus cosine theta over theta will be 0. Okay, the way that we need to find like this instead of plug in, because you should be able to see at first that if you plug in it becomes 0 over 0, right? So that's why we manipulate it this way. Okay, so now we are prompt to find a derivative of sine and cosine. So let's see the sine first. Okay, so we recall that the sine of a plus b, it is sine a cosine b plus what? Uh, cosine a sine b. Okay, and also cosine of a plus b, it will be what? Cosine a cosine b minus sine a sine b. Okay, be careful. Okay, this is a recall. Why is that? Because this one we are going to need f of x plus h, right? And here is your f of x. So it means that your input must be x plus h here, and then minus f of x, right? So this one you use the sine of a plus b, so it becomes sine x cosine h cosine x sine h. Okay, and then you manipulate a little bit by uh, looking at this one. Okay, just move it here, but the rest, this one, you have a you have a common factor as sine x, right? And then the rest is what? Is 1 minus cosine h over h. Okay, and then a limit your h goes to 0. We already know from that, from the previous example, that this one over theta, it goes to 0, right? Okay, we have this one goes to 0. Oh, here it is, right? And your h goes to 0. So this one goes away. Is it after finding the limit with the sine x as well? Because right now your sine x, it is a constant. So the leftover is only this term, but your h goes to 0. Oh, this term, look at it carefully again. We have sine h over h, right? We also know that this limit sine theta over theta is 1. So this one becomes 1. So everything collapse and then it go back to a cosine itself. Okay. So the derivative of the sine function become a positive cosine. Are we okay? So next, if we would like to find a derivative of the cosine, so here is your f of x, here is your f of x plus h, here is your f of x, okay, over h. So we use this formula, the cosine of a plus b. So it's cosine x, cosine h minus sine x, sine h, okay, over a cosine. Again, we just pairing as what we just did, okay. This one has no common factor, right? So we leave it here. But then this term, you got a common factor as cosine x, so you pull it out, and then this is the rest. Again, this one equals to 0, so everything gone. And here, sine h over h becomes 1 as your h goes to 0. Don't forget that you still have negative. So a derivative of a cosine becomes a negative sine. Okay, this is very important. We get. So now after we find a limit of these two trigonometric involved function, then you'll be able to find a derivative of sine and a derivative of cosine as follow. Okay. Okay. So let me just write it down right now what we have in hand. Okay. So first you may think that, okay, here can be the first one that we have. It is a derivative of a constant becomes 0. So the next one is a derivative of x raised to power r, where your r is any real number, can be r and then x raised to power r minus 1. derivative of the exponential function e to the x would just e to the itself. And then this one that we just have, the derivative of psi become a positive cosine. However, a derivative of cosine becomes negative sine, okay? So don't forget this negative one. Are we good? So we have these 5 main formula that we are going to use it later on, okay? However, before we end this section, let us like looking at this kind of limit more, okay? So actually from the limit as your x goes to 0 of the function sine x over x, we can further extend to have that a limit of sine of f of x over f of x will be also equals to 1 if the limit of that one inside equals to 0 as your x goes to a, okay, as your x goes to a. So for example, this one, here is your f of x, you see, there is your f of x, okay? And as your x goes to 1, your x minus 1, okay, this one equals to 0. So it means that this one, we can apply this formula directly, right? So it goes to 1 as well. However, if you look at this one here, you see that there is 3x. So if we need to use this formula, it must be the same f of x, right? But this one at the bottom, you only have x. So you can put the extra 3 here. But then if you put the extra 3 here, so let me just write it down over here. Okay, you put the extra 3 here, but you need to make it equal. You put the extra 3 on top. So that actually you put only 1, right? Right, a number 1 multiply, but that 1, it means 3 over 3. So here, we already have your f of x, right? And we know that a limit as your x goes to 0 of this one, this time your f of x is 3x is 0. So this one, a limit becomes 3 times 1, which is 3. Are we okay? Okay. So how about this one? You see x minus 2. This one also has x minus 2 hidden. So here we got x minus 2 side of x minus 2 over x minus 2. And let me just move it a little bit. And what? And 1 over x plus 2. Can you see? So this one, it is like the previous one, right? A limit of this one as your x goes to 2, it will goes to 1. But this one, as your x goes to 2, you can just plug in. So you have 1 multiply 1 over 2 plus 2, which is 1/4. Okay. This one as well, look at it carefully, even though we used to have this kind of problem psi of 1 over x, but this time your x goes to infinity. So can you manipulate this one into the same f of x? So here's f of x, right? So you need side of f of x over f of x. So you can see that actually this one, it is side of f of x over f of x, right? And you know that the limit as your x goes to infinity of your fx, which is 1 over x, is 0. So it means that this one is like, look like side 0 over 0, it will be 1. Okay, so roughly speaking, this one saying that side 0 over 0, it will be 1. Okay, this is like roughly speaking, okay, roughly speaking, but it must be the same 0 in order to conclude that the limit equals to 1. We okay? How about this one? Okay, how about this one? You see immediately that, hey, here's the square root, right? So the first trial that you may think of is to use the conjugate of this square root, right? So you multiply by a plus, okay? It conjugate, and then over this one you carry your sign, and then square root of x squared plus 7 plus 4, don't forget. Okay, so what is it on the top? Okay, after you multiply the conjugate, it will be x squared plus 7 minus 16, right? Which is what? X squared minus 9. So you can separate, you can do a factorization of the top, right? So it will be the limit as your x go to 3 of x minus 3, x plus 3 over side of x minus 3. And then don't forget the square root, okay? And then plus 4, okay? So now here is not really a sine 0 over 0, right? It's not really a sine theta over theta. So don't forget that what we have is the sine theta over theta, it is 1, right? However, if you flip it, it's still a 1, right? Because your 1, as you flip it, they are the same, okay? So this one as well. So either sine 0 over 0 equals to 1, or you can say 0 over sine 0 is also 1 as well, okay? However, again, this is just roughly speaking, and it must be the same 0 in order to conclude. So you see here, as your x go to 3, you got 0 over sine 0, and they are the same. So you can conclude that this one equals to 1. And then as your x go to 3, this is 6 over, as your x go to 3, you have a square root of what? 9 plus 7, and then a 4, okay? And 9 with 7 will be 16. So you have 4 again. So you got 6 over 8, which is 3 over 4, right? Right. So here's the limit of that one with the sign. Okay, we good? So try to use this one again with all this problem. Okay, so let us do it together. Okay, so for this one, actually the tangent is nothing but what? But it is a sine of 2x over cosine of 2x, okay? And then this one also x squared plus 2x, right? So here you have the common factor, and what you need, you really need to produce the same 0, right? With the side you see 2x, with the bottom you need to see like sine 0 over the same 0, so you need 2x as well. So you see here that you have a common factor, right? So here you have sine of 2x, and then that common factor x, and x plus 2, and cosine of 2x, okay? So how can you manipulate into the same 0? So you put a 2 at the bottom, and then you put a 2 on top, so that it cancel, right? So here, the side of 2x over 2x, it becomes what? As your x goes to 0, okay, it's side 0 over 0 with the same 0. So these two carry, so you got a 1 out from this, and then 1 over, as your x goes to 0, you have 2, and cosine 0 is 1. So you have 1 out of it, okay? Okay. Now, for this one, okay, same thing. Remember that what we have done is the what? 1 minus cosine theta over theta will be 0, right? So it's look like 1 minus cosine of 0 over 0 will be 0. This is again roughly speaking, but it must be the same 0, okay? So here you have a cosine square, 1 minus cosine square. So you may think of 1 minus cosine and 1 plus a cosine, right? Over that one, you can pull out y square, okay, and 4 minus y, okay, just like that, okay. Oh, this is not good, sorry. This is not good. Why is that? If you do it this way, then this one becomes 0, right? But you still have one y left with your y goes to 0, okay? This one, I'm sorry, okay? It is there's a better way. You see, what is it? You see also a 1 minus cosine square, right? You should be collapsed into a sine square. And then at the bottom, you already have y square, and then 4 minus y, right? So it is the same as what? You have sine y over y, and then the whole thing square, and then 1 over 4 minus y. So this one again, your y goes to 0, right? This one goes to 1. So we got 1 and then 4 minus 0. So you got 1/4 out of it, okay? How about this one? How about this one? This one may be a little bit tricky, okay? You got sine of 2x over 3x, and then this one can be sine x over cosine x, right? Right, because your tangent, and we don't really know about the tangent, but we know about the sine, cosine, so we try to manipulate it this way. And it can be what? It can be a limit as your x goes to 0 of the what? Sine of 2x over 3x cosine x minus sine of x, and then over cosine of x again. Then you flip it, okay? This one is just to manipulate the thing. So we have a cosine of x, sine of 2x over 3x cosine of x minus sine of x, okay? Here's another technique, okay? What we have in hand is a limit as your theta goes to 0 of sine theta over theta equals to 1, right? This is what you have in hand. But right now you see two of the side without any x, right? Without any over x there. So what you can do is to manipulate it this way, okay? You are going to divide, okay, the top and the bottom by 1 over x, or you just actually introduce this one both on your top and on your bottom. So what is it on your top becomes? So it becomes cosine of x and then sine of 2x over x here that we just introduced. And this one, your x must be distributed into the two terms, okay? So the first term, it just become 3 cosine x. The second term, it just sine x over x that we just introduced, okay? So for this one, as your x goes to 0, it immediately goes to 1. But this one you need to manipulate by 2 and 2 so that this one goes to 1, but you still have left that 2. So as your x goes to 0, the first term becomes 1 and 2, and then this one becomes a 3 minus 1. So you got 2 over 2, which is 1. Okay, so this is the techniques that you may need to look at. Okay, so we would like you to go over the exercise 3.5 from number 39 to 48 by yourself. Okay, so let us stop this video clip right here, and hopefully you still remember what we have done here for a derivative, and also actually for the limit, okay, which is a what? The limit as your theta goes to 0, sine theta over theta is 1, and the limit as your theta goes to 0, 1 minus cosine theta over theta equals to 0. Okay, okay, these two also what we have done for the whole video clip. So we'll see you then. Bye bye.